This is the video for Unit 5, Lesson 4, Graphing Radical Functions. The goal we have is to identify characteristics to graph a radical function. So the first one we're going to look at is the square root function. And it looks familiar, hopefully, because it looks very similar to when we talked about transformations. For absolute value functions, quadratics, and cubics. So it has that AH and K that we've seen before. So the square root function is the parent function is just going to be f of x equals the square root of x. We talked a little bit already that the domain, you're not allowed to have negatives under a radical. So our domain is going to be 0 to infinity, and it's going to include 0. And our range is also going to be 0 to infinity. So if we take a look at the graph, you can see it has an endpoint at 0, 0. And it goes infinitely to positive infinity when we go to the right. So the end behavior as we go to the right is going to be to positive infinity. But it has an endpoint. It starts at 0, 0. For our transformations, we're going to still see AH and K like we've seen before. So the A is going to dictate the shape. So that's a stretch, a shrink, is it reflected? And HK is going to actually be like I'm going to call it our endpoint, right? So that's where the graph is going to basically be starting. And we're going to be going from left to right. So that's our left endpoint, and then it goes to positive infinity. Or it might, when we go to the right, it might be going down to negative infinity. So for our square root function, graphing it, we're going to first identify our AH and K. So our A value is a 2. That's what's in front. Our H is the opposite of what's underneath that radical, so that's negative 1. And then our K is a negative 5. So our endpoint is going to be negative 1, negative 5. So if I plot negative 1, negative 5, it's going to be in quadrant 3. And my A value is 2, so that means I'm going to go, if I go over 1 unit, I'm going to go up 2. And then from here, I can actually, if I want to do a table of values, I can, but I'm just going to do my best to kind of sketch. And it might not be a perfect graph, but you get the rough idea. It's going to be a little more stretched because there's a 2 there. And it's going to go up towards positive infinity because it's a positive 2. And it starts at negative 1, 5. Our domain includes our endpoint, so it goes from negative 1 to infinity. And then since it's going upwards because it's positive, it goes from negative 5 to infinity. For number 2, it's kind of the same thing. So I'm going to go ahead and identify my AH and K. So my A value is actually negative 1/2. My H, there's nothing inside there, so it's a 0. And my K is negative 2. So my endpoint is actually 0, negative 2. That's where I'm going to start my graph. My A value is a negative 1/2. So that means if I go over 1 unit, I'm only going up like a half. So it's going to be more of like a shrink. And I'm just going to do my best to draw like a sketch. It should look something kind of like this, right? So it's like basically kind of almost like a really, almost like part of a parabola, if you will, because that's really what we're going to talk about later. It's like an inverse of that. Our domain, you can see that it's going to have the H value in there. So it goes from 0 to infinity. And my K value is going to go from, you can see it's actually going down, right? Because it's a negative. So it is going to have that K value in there, but it's actually going to be negative infinity up until the highest point, which is negative 2. So if your A value is negative, it's going to be going down, and you're going to have that negative infinity to 2 with a bracket. All right? The 2 U tries you can try out. And then the next piece is talking about cube root functions. So very, very similar. The only thing is, unlike a square root, you can have negatives under a radical for a cube root, right? So we can have, I could evaluate the cube root of -8, for example, and get -2. So I'm allowed to have negatives under there. So that's why that graph can exist in the left and the right. So the domain actually goes to positive and negative infinity. And actually, let me change this right here. So it actually should say it goes from negative infinity to positive infinity. And then the range also goes from negative infinity to positive infinity. So that should actually be the same for both. What we have is our endpoint. Instead of an endpoint, we have an inflection point. So for the parent function, it's actually 0, 0. That's kind of where that graph does that little pivot. We call that an inflection point. And that's going to be h comma k. And you can see that your a value, you're going to go over and up, and then just do your best to draw like a little sketch. So for this first example, we're going to do the same thing. Again, it's a cube root, so we want to make sure we know what our parent function looks like. It's going to look like this. And so our 8 value is a 1. Our h is -1. Our k is -2. And the inflection point is -1, -2. So I'm going to go to -1, -2. That's where our graph's going to do a little pivot. Our a value is 1, so when I go over 1, I'm going to go up 1. I'm going to go, and then I'm actually going to do the same in the other direction. And then just do my best to draw kind of like a little S shape, if you will. The domain and range for these is going to be all real numbers. And that would be it. And then finally, the last one for our a value is -2. Our h is 3, because you take the opposite. Our k is 0, so our inflection point's 3, 0. -2 means I'm going to go over 1 and down 2. And then same thing in the other direction. And then just do our best to kind of show that we have like a little bit of a pivot here. So, and again, it doesn't have to be perfect. You're just kind of doing your best to do some sort of sketch that goes through those points. All right. If you have any questions, you can feel free to ask them in class, sign up for T-Bolt time, or go to the center.